So, uh, yep, is it recording now? Oh yes. So, is this then working as intended? Hopefully it is. No. Oh, it is recording. That's fine. So this is the thing. So we got the verb noun ASAC. What is the verb noun concept, guys? Verb noun concept. Verb, the doing word, the action, and then the noun, the verb, the to do, to act. It's basically the concept of modeling that you're trying to act on. It's like the doer in the work. But the purpose is to or to act, to show, to assist, to spawn. It's what you're doing to connect. To that's next is to connect. Those are verbs. Noun are things just acting upon. The car, the to do, to show a house, to see a person. Those are verb noun classifiers for ASFT. This was filling on ASFT, which is probably basically using ASFT via tensor model to process information that is seen and relaying over the second patterns hypothesis equal to user playlist. Pattern matching crisis, verb noun semantics, consciousness paradigm, real world protocols, physics of graph algorithms. Okay, we're gonna start with the pattern matching crisis. Basically, what is this? Binary logic kills. Yes or no. Everything's no. Every question, even small as big questions, it's not yes or no. You can get some answer. You can give some response that is not a yes or no. It answer that's meant to be yes or no, because you may not know the answer, but it doesn't add up to the answer, because you can bridge it with by saying without saying yes or no, especially when there's some kind of interpretation in it, a lot of interpretation. For example, something I want to I know ahead of someone's gonna do ahead of time. A question I'm gonna ask someone, a child, are they gonna do ahead of time, but they're not gonna do it. Like a promise to the future, but did you clean your room? Are you gonna clean your room? Did you clean your room today? Do you clean your room today? Today, maybe it's 12 1 p.m. 1 p.m. Did you clean your room today? So you have the morning time to do it. Yes or no? And the child says, no. So you have to evening to do it. That'll be in my framework 6 hours daily. So you get to 6 p.m. to do it. That's evening time for children. Then did you clean your room yesterday? They say no. No. So you get 2 days. So now you say to the child, will you clean your room tomorrow? So they say yes. But you give them 3 tries. Yes, for tomorrow. But tomorrow is not today. So how you gonna show if they didn't clean them today or tomorrow? They're gonna clean some not. So that's the binary logic. It kills the state of mind, because you have 3 days a week. So every 3 days you basically start to kill the student. Like me, I clean the room every once every 2 days. So every once every 2 days, but once every 3 days the child is still fine. Because you're an adult, so it's very good. Once every 3 days. So that's the goal, that you ask the child to ensure they do the job, because before they start getting penalties or whatever, the position or whatever that is, give them some chance, because they're children and they're still learning and they're growing into that full form. But the current AI systems, if then else rules, are basically roadblocks, because there's accident in the equity systems, because it's like if else is too binary. If you clean your room, I'll give you a present. But they don't really care about your presents. They care about the game. So they can just go, yes, I clean my room, without acknowledging what you say. Which is what the pattern matching, because you're just matching patterns and learning bad behavior. Because you don't have the right resources to tailor to it. The same with AI systems here. You don't have the right input data to give you a full picture of what the real world consequences are. Which is because the child will grow up a child, and then each child's inside his room every day. The child will be dirty, messy, and then be disorganized, and hyper fixated on the game, and not actually achieving his full potential, her full potential. And that's what I'm saying. Think of it like a tree. A nil is no value, and yes or no classifier. This is too rigid. An example. You see, I'm adult. I'm talking to my friends. Do you like Call of Duty? Do you play Call of Duty Warzone? Do you play Battlefield 6? Open beta. And I say this question. Ask me. I ask the question. So I'm gonna ask you. I say, Yeah, but I'm not deleting anything. I say yeah, I downloaded it. I downloaded basically. I say yes. This is but usually because what should answer? So this answer should be no. So I said no, no. Now if I say no, then I say why not? Because I'm poor. Because I'm why not? Why did you not play it? Those are questions. Is it because why did you not play it? So now I should give more structured answers. Why did I not play it? I should be saying I didn't play it because I had wasted time. I missed my room was basically had shopping to do. So I should be given. Conveniently, because we are adults, we plan something to do and we didn't do it. But the problem with this kind of framework is the structured questions are yes or no classifiers, but the yes or no classifier cannot be always yes or no because there's a deeper hidden why I did not play that game. Which like a black box. I'm trying to make it a white box, but it's hard to relay it because this thing is stressed to me. And so basically, if I don't play, why do you not play the question? Because just to go to a point, what is some kind of structured question to ask, and it's true. So which is kind of the nil layer, because I don't expose to someone else how I relay it information. But I'm saying that I don't play Battlefield 6 Open Beta because I didn't like Battlefield 6. I prefer Call of Duty. Some kind of reason demon. I'm like, but it's like a yes, nil, no tree. So the nil this is a binary tree, but it's a binary tree. But the nil stipulates is some arbitrary reason why you didn't do it, related to the circumstances of that decision. That's what the verb noun clause is meant to do, really pick up for silent failures, things that we don't really understand in our frame of reference. Because if someone wants me to play Fatal Basic, there's no reason I should not have the time to play Battlefield 6 Open Beta before it closes as planned. Because it's really rigid, so because the nil is like other ways it can be. Basically, it's a binary tree. It's too rigid. It's too rigid. So the binary tree is too rigid, and that's what I'm saying. It doesn't really get the full picture across via interpretation. Of that rotation model. The thread back so nil or epsilon is a state, default state. You enforce because if if the consensus is broken, or the permission is broken, the system has to consensus give you a new information or what you do. Basically give you basically curse is just if else are bias. The rules are equal, clear. Block quotes. Block states happen when patterns misfit. No confidence checks, no protection bar. So the idea is that it's a consensus system that protects you over the verb now pattern matching process. There's no pattern matching method. There's no basically pattern matching is just a pseudo classifier in this model because it's like a fake classifier. Everything's not used no, especially when you have a different way to frame it in a different context. Like so think of it as context bound polyglot system. A more concrete, better example I'll give you guys is the context. Say I say a message to pass a message to my friend via conflict note, and it got intercepted by some kind of someone just basically I left the note on my friend's desk Ryan. Ryan. I said Ryan. I meet me at 3 p.m. after school in the park. Let's smoke tobacco and talk about uh, our party tomorrow. Oh, what's this going on? No, our party. Oh no, this will give me a headache. This is not even like. Let me just lock it. Basically it's now locked. This should just should do. So basically, the party one. There's basically this letter is like made for Ryan, but Ryan is not in today. So the Ryan is like this Emily. So Ryan is there. But I leave the message on Ryan's text in the morning. And it's like a drawer, Ryan's drawer. But it's not his name on it. There's no name on it because there's no Richard Roses. And mine was we're just sitting in positions in the class. So the idea is that we have ways to. So Ryan normally those my ideas, but if someone comes in, someone else like Jamie. Jamie is sees Ryan sits not available and sits in Ryan's chair. He sees Ryan's access in the message in the drawer. That message was for Ryan via interpretation because he's meant to see the message. Ryan's the message. Not necessarily Ryan wasn't in for that day, so Ryan couldn't get the message because the protocol wasn't for Ryan. But the system sent it to the wrong because he didn't expect Jamie to be Jamie to set that. So because we misclassified the context context of interpretation for interpretation. So we interpreted that Ryan's gonna be there on that day for the work, but he wasn't. So we got intercepted by Jamie, who sits in Ryan's chair today, and then Jamie gets the message, and then wasn't sure what the message meant. Because Jamie's chair was not even because you know just use clumsy, just want to say anyway. So Jamie gets Ryan a message, and then he just can cause a lot of chaos. But you know, if he knows what the message means, but he doesn't know what the message means unless I have his name in there. Because you know, it's just yes or no. So in this protocol, the yes or no framework would be like, did the stream or the stream get intercepted? Because you know, I can write something to someone and not tell them what I mean. And you know, by interpretation or full message semantic meaning, they can get themselves what they need out of that zone. Which is what I'm saying. So a solution to this is the binary classifier. Because if you classify binary, it just goes to where it's meant to go. But you know, we get the this is called homogeneous type. So basically, if I'm trying to say one is modeling the true, the valid cases, true positive, false positive, homogeneous cases, and 0 is modeling the negative cases, false negative, false negative, false true negative, false negative, false positive model. That's 1 and 0, where 0 is an epsilon state. Yeah, 0 is an epsilon. Then we can say x is the same as 0, but it's heterogeneous. So you can get heterogeneous classifiers from sparse data, like, you know, qualitative and quantitative data based on the sparse encoding system. So the verb classifier will actually do it, and you get the circle. The circle will be the truth. So you get a 1 or a circle, or wait, basically, so no, let's do it all the way. So you get a 0 or circle. You know, basically, let's just make it something. Basically, the symbol is theta, 0 or theta, which means null or nil sparse data, quantitative data, and you get 1 and x, and then this means that the data is constant. Basically, if you switch between these 4 pairs of classifiers, you're actually controlling the computer's inside situation. That's what I'm saying. The goal is to show that there's some kind of polarity in the system, because you know system is regard to some kind of objective via the alignment of whatever is being pointed to at that time via the dual medium. Because you know, if I represent homogeneous data, the short-term heterogeneous data, and long-term homogeneous data in the system, system can remember for longer structure information, which is what the thing is going to do. So it's like based on lattice transformation, union, disjoint, and intersection, based on the homogeneous and heterogeneous model of storing qubits in a state of superposition. So you can always remember something, all of it, instead of superposition. You know, you can share the state of 0 and 1 with x is 0, because x is 0 at the same information but in different structure form. There can be nil or pass. You know, if there's no type, no memory, no nothing to remember, and that's the state. This is it's like it's basically trying to create some kind of memory system, like based on human, not human, like enzyme, because you know you get if I remember half, if I got my shelf, and I have some kind of elf system that puts books in 90 little boxes, and I get to the books at 01 squared, and I get new books. My memory shelf grows, my shelf has to grow. But if my shelf grows, that means there's something wrong with my shelf. Because you know the shelf keeps growing, and I'll never find any book anymore organized. That's the same thing I'm saying here. So the idea is to take the memory, which is the books that you have, and give them their own physical addresses first. Like, you know, not even physical addresses. Let me just put it this way. Basically, the shelf is dynamic, because you know it scales with every book you have. Things you are meant to do in the future. What I'm saying. Let me think about the memory. So you get the shelves. The shelves take the books take half a quarter of the space. A quarter of the space. That'd be like a quarter. That'd be one book per one section of the shelf. What is the heterogeneous or heterogeneous? 0 1 0 1 0 0 1 0 1 or 0 1 or what? An XO or XO, which means X means true and O means false. But nil operator epsilon, heterogeneous epsilon. Basically, I'm trying to compute the heterogeneous one based on XO nodes and crosses, which is what I'm saying. So 1x is cross. That means the data is there. And it can be found with some users can basically find all the set of data, and you get O means nothing is there, not that thing. So the idea of this, for example, is to have the shelf not grow, but the information shrink. So if the information is the process, it's like you don't have to load up the artifact. You just load up the same shelf, but the information is just a small segment of it. For example, if the information is compressed by a quarter, like it's a fourth of its original dimension or size. So you have like a megabyte byte. Byte is a byte, and you get a megabyte, and you get kilobytes, and you get gigabytes, and you get terabytes. So you get a byte. Bit is 1 qubit, 8 bytes. Megabytes you get 16 bytes, and you get kilobytes you get quadruple 3 times 16. That will be 1,000 plus. So you get a byte, 8 bits, 110 bytes. 10 bytes, you get 100 bytes and a megabyte. A kilobyte is 1,000 bytes. A gigabyte is 100,000 bytes. 100,000 bytes, kilobytes. And the terabyte is 10,000, 100,000 gigabyte. Because you get the 1, 2, 3, 4, 5, 6, 7, 8. So basically, if you have like 100, 1, 2, 3, 4, 5. 1 GB, you are equivalent to 1 GB, you are half of 1,000 GB, and that's the idea to ensure that you are remember stuff. But if I cut the space in for this 1 GB in the shelf, and then for the book, and it takes let's say 1, 2, 3, 4, 5. Keep it in this GB. Takes 10 GB. 10 GB of memory is nothing in this book series, like in a book. So this book takes 10 GB of space in the shelf, and you put it on the shelf, and you have basically it takes 10 GB. So you want to make it basically you compress it and make it a fourth of its dimension. So a fourth is 2.5 GB. GB, because it's 25 divided by 4, 2.5 GB. Oh no, wait, 225 GB. No, basically going to 25 GB. Now, 25 GB is a very small space to compress it. So this a quarter of the 100 GB for the book equals 25 GB. Which I'm saying here is the good thing to do. But 25 GB is good. So what you gotta do is ensure that once this 25 GB, the diamond scale, the book has some kind of allows you to re-index the system, so you can re-get it, but you're gonna get it based on the updated address of the entire city. How you organize the book. So if this 1/2, the book should scale by another 2 dimensions. So that's the x and y close. If the book is shelf is 10000 GB, that's 1 GB, and you get 2 GB. You double it 2 GB, so you should be to store more books but on less space. So you get 2 1 100 1000 100 1, 2, 3, 4, 5 2,000 GB. So 2 GB, you double it. So every book you have is considered 1/2, 1/4 of the memory is nothing. 2.5 GB to store it in the dynamic allocation system, because it's heterogeneous there. It can be stored in a way that's heterogeneous to be indexed based on nexus search. If that's because you get Nexus search do the same thing. Basically, that works on 3 nodes for the character set. Basically, the use of this set is indexed because it's because the space-time complexity is double, so you don't have anything you're indexing at over log n, log n unless no matter the space you added to update service. But that's kind of idea of it. It's meant to try to be aware. The more the storage knows, the more those storage gets better at sorting it out and finding the stuff, and that's the idea based on whatever you put in it, so you can find it too. Missing information. So basically, on my show, part of my show basically, they never asked on my show before action. The minimum concentration before further words for show operation. But that's what I'm saying. So check is like do I on my show? Do I know what I'm doing? It's more ontological. So okay. Oh, what am I saying about this? Basically, driving car from pairs to graphs. So the KNN clustering algorithm is basically, so you get a driving car, a driving car does what? Becomes a network meaning. So this is the main idea behind the search indexing operation for the verb noun concept. Driving car. So driving car becomes a network meaning. So the idea is to give context information based on classifier pair. Things that is classified because if something is there and it's classifiable, the issue will just instinctively do it based on 4D, 32, 3D, so we can get meaning out of it. But we are trying to use bubble topologies to map or knowledges kind of structures to classify things. For example, driving car becomes a network meaning. The structures code, context, casualty, and risk produce like. So, what does that mean? So, a person operates a car, navigates, a road has state, and a block is confidence. So, example, the person operates, I am driving a car, and the car navigates, moves from A to B. The road has a red light. The car, the comfortable and the confidence score. If I'm blocked, I have the confidence to do something else via the red light, so I can turn on the next junction before I go to the junction when the red light is. That kind of idea for the ES system, because the car is driving, but it's actively watching the streets. It's not just driving to match patterns. It's driving to learn from the whole world view of in the real time. That's the idea of the verb noun philosophy via the diagram graph pair. Because they can just match one kind of unit classifier, but you focus will not be able to scale like a fast car, a slow car. It's all verb noun pairs, and so on. This one is seeing a small child, a small child, a small man. It's not looking for ghost thing, just looking for the confidence. How's that good? Consume confidence. Semantic edges carry confidence when if the story is both drugs behind the biological bots. This is like contextual, so you have to understand from context. It's like the interpretation of the context is very important because the context. If I give you some kind of scenario which I call a context. The context must be enforced via interpretation. Because you don't know what the information is about, so you interpret it. So you start interpreting. So there's a man. He was a man. He was a woman. She was a beautiful. But she was also evil. But she saw me evil. But I won't see that context immediately in him until she does something evil. So that's kind of the idea. If a woman is evil, a man is evil, it doesn't really matter. The system must enforce that his average or whole before human. The confidence is blocked, but it must be sure that there's no training loss between reliable action and something that's absurdly, insanely hallucination. And the context is what's preferred based on the parser. So the verb noun parser will be like, am I a smart man or like a flying dog or something? What's hallucination or not? Something that's real, and so the ear wouldn't get overloaded by information. It sees as not real. Conscious pipeline. Receive raw signal, validate it, decide partial action, and let me drink some water. So that's the idea. You are perceiving, validate, and decide. So is it what I'm seeing? I'm perceiving stuff. So you're observing stuff. Basically, it's trying to mirror raw sensory or navigation via the open sense 8x6 matrixes. Full awareness. Based on, because the listening, you start with a noise. You shouldn't need to accept noise, background noise. First, you don't even tell it to classify stuff. You started to perceive the raw noise around the world and start to classify it. You don't give it an object in a frame of reference to classify. Like you don't make sure it's an apple, a red apple. You say, okay, I need to look at this image. Look at this thing and see whether you can classify it based on how it looks and feels in that frame of reference. If you can't, then it's not really working in that way you want it to. For example, if you have a walk cycle can I can look at people's legs and understand how they work just by how the feet sound, whether they're man or woman, how they stand, how their posture, their back, things that don't even involve the feet. Walking or the shoes, because I know that when they walk, when I look at their leg, I can classify them as walking upright, and seeing how they project themselves, whether they can call themselves or not. So the rosary rule is very important for me to classify whether they have eyes, nose, them. Protective barriers, and they're basically very much is for there for cultural degree. but the AI system doing it in the real world. But they perceive the real world and they try to get the job done based on frame of reference and see how the epistemological cost function how they track and commit to every action based on inverse kinematic testing over the kinematics test minimum action for molarity for like computational computational molarity barrier or safety fuse. The barrier is not a ship. It's a collaborative fuse that pops when certain. So basically, the idea of this is to show that consensus is not broken. So especially if an system cannot do it, it has to degrade, do the job before it makes mistakes. If it is right to fails, but that fails is a good thing because someone else can try to do it. It doesn't fail. It has to control to something. Maybe this operation or something. The AI doesn't know all, and it must not be taught to know all. Rule protocol. Rule kill decision tree. So object citizen, graph level person, barrier check blocked. A measure protocol break handle trigger pressure. So basically, if an object is detected in real time, it stops. The confidence drops. The epistemic control. It's no. The mind is stating, do I know what I'm doing now? And if there's if baseline on a 5% before or some kind of metric, the action is blocked. It starts to slow down. It starts to find different ways. But it doesn't continue doing the way it's doing. That's the idea. It's meant to give control back to user at some point. but it doesn't have to do that if it's safe. So that's the idea. You give full consensus to the person to act on it based on the status of things. Whether they're crazy or not. So. Graceful degradation. So when consensus fails, the system is not phrase. It requires additional sentences, narrow optional noise. The graceful degradation mirrors how the conscious model based on build, repair, and build, break, repair enzymes. How worms basically I believe worms repair because of enzymes. They have a lot of enzymes to do that. Then we get the amino acid over there. Then you got a graph algorithm. So the propagation of uncertainty is via the chemistry. So uncertainty is a natural thing in ES systems anyway, because uncertainty is we assess about a lot. We don't really classify a lot, but everyone must require to show. If I wake up, if an ES system wake up tomorrow in a conscious in the Mars, it'll be because what's my people? Where they go? It doesn't know what happened. So we even though put it there, we didn't say it was going. We said it was going to ask him shop. That kind of context is like a very how to do it because you have to probe a lot of uncertainty or who to trust. And if it's conscious enough, it will start questioning boundaries. Which is not what we want. Learn from edges. Edges is more information. Basically, if I have a node and the signal is not strong enough, but I still have no node and the edges make it look stronger. So that's what I mean, because the edges can be a node that I didn't really tackle if it's an income. So that's what I'm saying. It's like a sparse solution model for AI solution. If we just say got aging robust state, the idea of aging state robust. So you got the conscious AI. They're meant to speak with you, be with you for your life. It's not a weird thing. They're meant to make decisions that benefit you and not them, because they are meant to be your life at least once, at least for your whole life. Your whole life. That's the idea. So the 5-point focus for this skill is like your AI is helping you formalize your problems and doing your work. You aging with them, be aging in authentically with them. Whether it's nobody or not, you have someone to go to, and you are however they feel that you're communicating. So when you go in the real world, you're not a weirdo. In the relationship, you are more of someone that's tries to relay themselves without any roadblocks. And you can advocate for you to do that, which is more consistent bound application. Call for open barrier. So the publish is something that basically this is like infinite knowledge into infinite. Basically, we know a lot of things. But the kind of verb now classifier must ensure that we are actually getting the things that are better for us. Because the personal laws of infinite knowledge is like it's kind of like bad thing, especially when we are not dealing with the current schema, the current model of the verb now, whether it's like a silly dog or a smart dog or a funny dog. It doesn't matter the dog, but because there's some of a persona to them that will anchor them to themselves and I, and that's the open barrier. Because the 11 adjectives in terms of consciousness level state 50. Thank you, and this is my verb noun modeling concept. Verb noun modeling again is the idea of classification using key verb noun pairs, which are the classifier for things that are demographically or regionally bound, such as taboos. For example, again, if I give an example, sea blue, the sea blue is a color. The sea is blue. The sea is blue, but the sea blue is the color of sea blue. This is sea blue. This color here is sea blue. Sea blue here. Can you see the color? Sea blue. That's the color of the front page. So that color sea means it's blue, but the blue is a sea type. Then you got this color here. Now this is sky blue. See sky blue? Now this color is sky blue. They're the same thing, but they're different classifiers for it, because it's just a subtle difference based on how we frame of reference. So it doesn't really matter what we see, whether the blue, not one's lighter than darker, but one's more cloudy, more softy, has a different free sensation to it. That's the idea between the first system of the verb noun classifier to give you the most accurate ontological perspective based on your frame of reference and its frame of reference, what we will put at the same time. That's the idea. The verb noun concept again is a sea, sky, like sky in this air, space, time, etc., and the blue nature of the sky, clouds, so the kind of feeling they can progress to a story. How the sun, how the sea met the sun, how the sea met the sky. It could be a story of leveling the sea level. That you can do, and you can write that. Assist you writing that thing without bothering you. Ontological. But I have something on my phone today. Hey, Nambi, what's my phone? Oh, Nambi, don't. Oh, Nambi. Basically, I have something on my phone. I have to go and try to find it before I go. Oh, yes. Oh, no. Oh, I think I put my phone, Nambi. Oh, basically, what do I have on my phone, Nambi? 1 second, guys. I wrote it down here. So it should be starting now. This is kind of starting. 1 second, guys. Before you go. So the verb noun concept is like modeling the process the process systems for consensus to based on what you want to do, because you're trying to basically don't want anybody depressed doing nothing. What do you have an AI, built AI? You can use to also give them consensus, but they are bound by consensus. They are open sense compliant UAIs. Like in an AI exchange with you. But you got the consensual you. I want to give my consensus to do that thing. Basically, what I'm trying to do now. Oh, I can't even find my notes, man. Sorry, guys. Sorry, guys. I'm just to find out notes before I go. Basically, I got my notes here, guys. I usually just get it right. But if I don't get this notes right, it don't really matter when I get it. Let me try to close this up. This could be another video, guys. Should I close it? Okay, let me just close it, guys. Take care. Have a look. That's now. The idea is to classify the things by starting by with a noise. Think of it like a Perlin noise. Perlin noise, trying to use Perlin noise to model the signal of input for the real world and give that a Perlin noise in the data set for the thing you're trying to classify. And the AI should be able to take out Perlin noise, or not white noise, Perlin noise to decipher the noise. Basically, the thing of basically, you see this area, there's a book area, this blue, sea blue, but the computer doesn't know it's sea blue. So you take this noise, you take this book, this color here, and call it sea blue, and differentiate for certain nuances between sea blue and sky blue. That's kind of the idea behind the classification. The AI must look at it and use the Perlin, decipher that basically be noiseless. Take the Perlin noise and see authentically based on the gradient of the class story system. The area of the book should be blue and says sea blue, but that area is highlighted from the depth in depth. It doesn't highlight the noise, because if you highlight the noise, that means it's wrong classified. So you can tell it's classified in conclusion. The verb noun, you look at it and classify it correctly. That's the idea. You take the two side by side. You can look at it. Oh yeah, the verb. The AI system has a phenomenological, ontological perspective. It has to classify things not by the shape or size, but by the form, structure, and the verb noun, form, the structure, and the form. Like the book is structure and the senses of specific. So the form is like the four corners, the form of the shape. The form, it takes the kind of maybe it's like a water in a liquid bottle, or like some kind of form. Like a book has right corners. To it, says book, and you get what the system is more flexible because it knows what it's doing based on the compliance of the whole system. So that's the idea. I got my phone here, just trying to find this thing. Anything else, Navi? So that's the thing. Yeah. So basically, I'm trying to log into shell. Consisted by dynamic objective reality bridge, signal space-time micro system. So that's you're trying to bootstrap a signal activator because the signal is the person's ontological nature, being, and way to do something, and that's what I'm saying. It's sparse modeling for the form, the structure, and the classifier to know something before it does it. Because Perlin noise allows you to do that more accurately than random noise. Random noise is too noisy for the ears to pierce through and see something that you can take as meaning. So you have to use some kind of pseudo noise that can be deciphered quickly. But basically, if you put an image there, the image there, you can see the AI can see you through the camera lenses, but you don't train the AI to interpret. You train it to filter filter through the data set and create the first flash. And that first flash is what it sees of the system. That flash is like what is being classified in that state of mind. It's basically it's removing the rigidity of the system to you, so you don't give it rigid. You just train it, but when rigidity, you don't be rigid with it. It's no rigidity in the frameworks. For example, obviously if a is a 1 or 0 to a 0, that's because the AI 1 or 0 has an epsilon state which is noise, and the noise is polluted, so it gets it wrong and thinks it's a 1 or 0, but it doesn't think it's a 1. This is 1 or 0 classified down. But since this is 1 and 0 or 0 to 9 numbers classified down based on what you draw. But you can have the other one X or these are structure. These are structures. The form structure based on what you're trying to attain in real time. Okay, thank you guys. Have a lovely day. What am I doing now, Nandi? Oh, the thing is still up. This is to top patch off, and I'll turn it off. Oh my days! I wasn't even recording. Oh, I was recording.